Alrighty, let's do some feedback on your final project oral presentation. Okay, so what we're addressing is the multiplier. Now this is the one I'd actually made. What I would try to highlight is that this is the multiplier and these are the op amps, and look at the fact that it takes up so much area on a chip. So I would kind of highlight that with a thought bubble or something like that. Um, that looks pretty good. Um, I know you might be running out of time, but you really should use your own equation editor rather than cutting and pasting. Um, that's pretty good. Again, you're taking it from the paper. That's okay in this context, but the figure is kind of crappy because it's an old paper. I would suggest for your final report to make your own block diagram. I know you're running out of time, but so we have our impact on that. Now here, I would, oops, try to make the math a little bigger. It's going to be really hard to see in the back of the room. All right. This is a great summary, but it'll really be too small, right? Um, so either this thing could take up the whole page or try um, to get, like, I don't know, do you really need the name? I mean, you kind of need the names, but just try to you can say these things, right? And then just make this as big as possible. All right. Um, and yeah, you're kind of dropping an Excel worksheet in there. That's not a when you do a table, you got to do a real table. You can cut and paste it into a table, just so you know. You don't have to retype everything. Same thing. All right, those figures look pretty good. All right, that's still going on. I guess I try to provide a little bit of context here of what's being multiplied. That each one is something held constant, right? And then the other input is swept. I would also probably show that, it looks pretty linear in here and that it's kind of rolling off. Now, these are kind of too small to see, right? You got these big words, and that's great, but also I would really do the um, like over here. You've added the total harmonic distortion, but this figure is like it's impossible to read. Um, yeah, it shows that it's done in cadence, but Um, and this, I think you don't really need this one. That was like kind of a talk, kind of showing is it exponential or is it squared, but it's kind of confusing. And then that would leave room for this one, which shows, by eye that it's squared. All right. Um, and so here, yeah, you would really want to measure the turn on turn on the FFT feature of the oscilloscope and actually measure those things. I mean, this is what you really built, right? Sure, these show the range in which it works, and I would make sure to talk about that rather than just like this is where it's working. All right. Then yeah, you can say then we tried it, in 45 nanometers. Um, this is a little bit rough. Um, um, Maybe delete this one, right? But this picture doesn't really show what's what, okay? Um, it should have been one board, it should have been like a board and then everything wired. You really just soldered things in and then soldered the wires. Now, I might have talked about doing things in subcomponents, but it I can't see anything. That could just be a random bunch of stuff. I wouldn't really go from -5 to 5 because it's clearly not working. So I would just drop this one, right? And it was supposed to go to -2.5 to 2.5 because the power supplies, if you see over here, right, are 2.5 and 2.5. So you might want to make that a little bit bigger and then not do that because I mean it's clearly not working. It's going to make you. And again, back here, get rid of that, and then what you can do is expand this one so that it's easier to see. Okay, same thing. All right, but that's a good job. We made a lot of progress, and we can. It'll certainly set up the next students for next semester. All right, good job.